Hello, BlackHat. Thank you so much for inviting me for this talk. In this talk, we are going to look at VET, which is a free and open source tool for identifying risks in open source software components. We will see how VET is different from other SCA or software composition analysis tools. And we will most significantly see how to use VET's policy as code engine in order to define policies which match the risk profile of your organization in terms of consuming third party or open source dependencies, so that you can use VET as a guardrail to prevent introducing new risks, new open source risks in your application. So join me in this journey of identifying and protecting against third party open source risks using VET, a free and open source tool. First, let me introduce myself briefly. My name is Abhishek Datta. I am the CTO of a early stage startup in cybersecurity space called SafeDep. My current focus area are software supply chain security. I am also exploring a bit about LLM security as well. More recently, I have been working into platform engineering, DevOps, SRE, as well as a bit of security engineering, but more from a product security perspective. I like developing and contributing to open source software, especially related to security tooling. I have been a security researcher in the past life where I have worked in finding vulnerabilities, writing exploits, as well as spend some time reverse engineering and doing malware analysis and those things as well. This talk will be structured where we first look at how VET is different from conventional SCA tools. Then we also look at what is policy driven vetting, why do we care about it, and why we consider it as an important feature in VET. Then we will look at VET's policy as code layer, where as users you can define your policies and VET can identify risks and prevent risk based on the policy that you define. Then we will put all of this together as a practical use case of establishing guardrails in CI/CD to prevent introducing new risky dependencies in your application. Finally, we will look at how VET can also be used to drive or at least assist in mitigation of risks in open source dependencies. But first, let us quickly have a look at the problem. Why do we care about open source vulnerabilities or risks in open source dependencies? Linux Foundation survey on open source dependencies and their consumption in applications found that any modern application constitutes of 70 to 90% of open source components, which means you as an organization may have a excellent product security practice to identify and fix vulnerabilities in the code that your organization writes and ship secure products. But is the product really secure unless you can also ensure that about 70 to 90% of your shipped product which comes from open sources are also secure, right? So that is the problem statement on which VET is built. How can we ensure that when we ship our product, it constitute not just secure code that our organization has written, but also it is using third party dependencies, primarily those coming from open sources, are also secure, reliable, maintained, and has the desired attributes as per our risk policy. Before we look at the various features of VET, it's worth looking at how VET is different from conventional SCA or software composition analysis tools. A conventional SCA tool works by scanning package manifests such as pom.xml or say packagelog.json or requirements.txt, very package manager specific file formats which defines the list of third-party dependencies for your application. So the tool would scan this package manifest and in rare cases the source code of your application to identify the third party packages and the versions to which your application depends. Subsequently, these SCA tools would look up a publicly available vulnerability database to identify all the vulnerabilities affecting a version of package that you are using in your application and list all the vulnerabilities that have matched that particular package version, right? So this is how conventional SCA tools work. Thing to note here is that conventional SCA tools would only detect vulnerabilities that are publicly known for packages. Many a times, packages which are low popularity, which are not very popular, may have vulnerabilities, but no one researches or discloses vulnerability in such low popular packages. But if you look at your application's dependencies and transitive dependencies, you may find a lot of dependencies which are really low popular or unmaintained. VET was designed to not just look at vulnerabilities but think of component vetting as more of a data problem. So from VET's perspective, VET has multiple data sources such as the OSV vulnerability database, the deps.dev package information API, the OpenSSF scorecard, the package manager specific data sources. For example, specifically VET uses data source from the RubyGems database. So VET looks at all these data sources for various metadata associated with discovered packages and package versions in your application. Subsequently, VET will pass on all this metadata to the policy layer where as users of the users of VET, you can write policies defining what is risk for you and what is not. For example, in some cases, you may only be interested in preventing dependencies that have a critical vulnerabilities, or you may want to prevent introducing or using dependencies which has specific open source licenses. Or say for example your application has a lot of vulnerabilities in third party dependencies. You want to it will take some time for you to fix those vulnerabilities or update your packages to fix those vulnerability. In the meantime, you would want to ensure that your developers only any new packages introduced by your developers are popular, does not have vulnerability, uses maintained libraries, right? So you can define policies in VET using all these various data sources. You can ensure that any new package which is introduced in your application meet these attributes, such as licenses should not be a given list, or the package should be maintained, right? It should not have a critical or high vulnerability. So let's get started and see how to use VET to do all the things that we spoke about so far. In this demo, we are going to see the most simplest use case of VET, using VET to scan a directory with source code. In this case, we have a Java application with Gradle used as the package manager. So we can just run VET scan in this directory and VET will automatically discover and scan the package manifests for vulnerabilities in third-party libraries. So VET is going to discover the third-party libraries, enrich them for different package metadata, and based on that, it will identify risks in third-party libraries. Risks that are not just vulnerabilities, but other attributes as well, such as version drifts or low popularity. We will see more as we proceed in the presentation. VET can also be used to scan specific package management manifests and not every single package manifest in a source code, which may be common in a monorepo. So let's see how to scan specific package manifests. So in this case, we are specifying that instead of scanning the entire directory and discovering all the package manifest, VET should scan a single package manifest for vulnerabilities and risks. VET can also be used for querying for specific information as needed. For example, let's say we scan a particular package manifest. In order to query for specific information, we first have to dump the raw results into a particular directory. So once the raw data used by VET is dumped in a directory, we can use VET's query workflow to find and show only the information that we need. So let's see how we can only list for packages that has at least a single critical vulnerability. The query workflow is particularly useful when you are looking for specific information because by default SCA tools produce a lot of information. Once you dump the JSON data in a particular directory, you can use the query command of VET to look for specific information like vulnerabilities, popularity, packages with specific OpenSSF scorecard attributes, and the different enrichment data that VET has collected for against the packages. We will see more as we see the policy as code capability of VET. As we saw in the introductory slide that VET uses a policy engine to allow the users to codify their organizational risk policy related to open source dependencies. Let us see more about that feature. VET uses common expressions language, which is a very simple language to define certain constraints. VET uses Common Expressions Language or CEL for short as its policy language. For example, you can write a small policy also called filter in VET's terminology such as vulns.critical.exist p comma true. This means it will match all vulnerability findings by VET where there is a package which has at least one critical vulnerability. Thing to note is that VET operates on packages and looks at packages associated metadata or enrichment data such as vulnerabilities, popularity, maintenance, OpenSSF scorecard, bunch of based on the data sources. In the second example, let's look at how we can define a policy in VET to look for unpopular packages. Here we are checking if there exists a package whose project belongs to GitHub or hosted in GitHub and it has less than 10 stars. This just want to make it clear having less than 10 star is probably not a measure of, you know, quality of a particular open source package. This is just a heuristic. This is just our opinionated heuristics on how to identify if a package which is used in our application comes from a popular source or an unpopular source, right? So this is how filters or policies are written in wet. Filters can be combined into a single filter suite as well, which in turn is used as guardrails in CI/CD. So we will see how to do that as part of the demo. In this demo, we are going to look at filter suites, a feature in wet where we can combine multiple one-liner filters into a group of filters with additional metadata like name, severity, etc. to create a filter suite. The filter suite is particularly useful when you want to create policies as guardrails where wet should fail a particular build, say CI/CD or anywhere else, if it finds a risk which violates your policies. So let's see how it works. First, we will look at how filter suites looks like. Filter suites are nothing but YAML documents where you write the same CEL filters that we saw earlier, but along with some additional metadata, like you define the name of the filter, you define a type, you add some summary, and then finally the filters, right? In this case, we are defining a filter for identifying critical or high vulnerability, low popularity packages, failing on certain licenses, as well as based on some OpenSSF scorecard attributes as well, right? So we will combine all of this into a single filter suite, and let's see how wet can use it. To use the filter suite, we will pass the filter suite argument to wet. We will also use an argument called filter fail. You will see what this means, and then pass the directory that we want to scan for packages and risks associated with those packages. You will see that wet will find the necessary packages and the package metadata, apply the filters, right? In this case, if you see, this particular package violated the filter or matched the filter OSSF unmaintained. This means this is an unmaintained package. It also found some filters related to critical or high vulnerability, right? So all of this are packages which violated the filters that we have defined in our filter suite. Finally, you will see when we pass that filter fail flag, it actually failed with a particular error. If you see the exit code, it failed with a non-success, non-zero exit code. This is particularly useful for establishing guardrails in CI/CD, which fails the build if WED detects packages with risks that violates the defined policy. We saw how to vet for policy driven vetting of open source libraries. But there are more features in vet that can help in discovering vulnerabilities in open source components from different sources, such as GitHub repository or a full organization. Scan SBOMs from formats such as SPDX or CycloneDX. Auto construct dependency graph for package manifest where the dependency relationships are not there, as well as vet also can assist in remediation of transitive dependencies, which is many a times hard to fix, because you won't be able to find out easily which direct dependency is responsible for introducing a transitive dependency. Wet assists here by showing a path from for a transitive dependency to one or more of direct dependencies responsible for introducing the transitive dependency, so that as part of mitigation you can update the direct dependency. But thing to note, updating a direct dependency may not always fix the issue, because there may be intermediate dependencies whose dependency constraints do not require updating the transitive dependency with vulnerability. This is a hard problem, but WET is trying to assist as much as possible by showing the dependency relationship. So let us see how we can do some of these things as part of our next demo. In this demo, we will see some of the extra features of WET beyond its core feature of policy-driven vetting of open source software components. We will see how we can use WET to scan GitHub repositories directly and generate a graph of its dependency relationships. So let's start by scanning a GitHub repository. I will also use the WET's ability to generate a graph report so that we can see the auto-constructed dependency graph. So WET will identify the package manifest in the remote GitHub repository, scan it, and generate a dependency graph. Of course, if you are scanning a private GitHub repository, then you need to pass the GitHub token. The scan has finished. So let us see what is there inside the graph. So this is how it looks like. WET generated a dependency graph in dot file format for the scanned package manifest. We can try to render this using the dot command line tool from GraphViz library. So if you see here, WET actually reconstructed the dependency graph for our example Java application. This dependency graph is actually very useful in mitigating vulnerabilities or risks in transitive dependency. Say for example, WET identifies an issue with this particular library, this Jakarta bind API. When you look at your package manifest, in this case gradle.log file, you will see sorry, not gradle.log file, build.gradle, which is actually used by developers to define or declare the dependencies required by the application. Gradle.log file is the file generated by Gradle for its internal consumption, which is so that Gradle don't have to resolve the dependency graph every time, and your build is predictable. That means the same version of libraries is used every time you build your application with Gradle. So gradle.log file is the internal file generated by Gradle. If you see gradle.log file, you will see that it does not have any dependency relations. It just have a flat list of dependencies that the application needs. Now, when you have to fix a vulnerability in your transitive dependency and you look into your code or your package manifest where you have declared your dependency, you will see that you have never defined, say, this particular bind API dependency in your build.gradle file, right? So how do you fix risks in such packages? You will have to find the top level dependency which introduced the transitive dependency and update the top level dependency, or define some constraints in your build.gradle file for a specific version, specific minimum version of a transitive dependency, and update your top level dependencies. So there is a bunch of work that needs to be done. Wet tries to assist here by providing a dependency graph for developers to look at and identify how a transitive dependency was introduced in their application. That's about it for this presentation. Thank you for listening. My name is Abhishek Datta. You can reach out to me via LinkedIn or Twitter or GitHub. VET is a free and open source project. If it helps you, use it. If you need feature, feel free to reach out to me. As the main lead developer for VET, I would love to understand what kind of features that you're looking for which will make VET useful for you. You can also join our Discord community. We have a bunch of contributors and users there. I'm also linking VET's open source repository on GitHub and the documentation portal for reference. Thank you so much and hope to meet many of you at BlackHat Arsenal.